captain on the special space flight, and I will be guiding you through an exciting journey across the universe. So, on our very first stop, which is very close to our home, there it is, our Earth. From about 45,000 kilometers away, you can see how beautiful it looks. This iconic image is famously known as the Blue Marble, and this was first captured by the Apollo 17 astronauts. So, before we continue deeper into the space, let us watch a short informative segment on how this remarkable picture was taken.
February 14th, 1990. The Voyager 1 spacecraft is about 6 billion kilometers from Earth, beyond the planets of our solar system, screaming toward interstellar space. Following commands from NASA, the spacecraft turns and points its telescope at a distant object, looking back from where it has come. The resulting picture appears at first rather unassuming, but magnifying the image, we are able to discern a small blue dot. There, in that glint of reflected sunlight, is Earth, the place we all call home. This, dubbed by Carl Sagan, pale blue dot, gives us a perspective of our planet we humans have never seen. Suddenly, we are distant and fragile, obscure and isolated within the cosmos. How small, how seemingly insignificant, barely a dot. No detail, no continents, no boundaries, no definitions of us one from another. We are quite simply human. And to survive on this speck in our otherwise barren solar neighborhood, we will have to work together. Let's go back a little further to December 1968. The Apollo program has begun, and Earthlings are finally orbiting the moon. It fills their views and camera frames. And then, appearing above the horizon, there it is, Earth. Breathtaking. So this is what an Earthrise looks like. Move forward 4 years. The Apollo 17 astronauts leave humanity's last footprints on the moon. But before they even arrive, they too make photographic history. What a window seat. This is our first look at an entire disk of the planet. From 45,000 kilometers away, we see the deserts of Africa, storms over the Pacific, Antarctica in all its ice-covered grandeur. This picture becomes known as the Blue Marble. But wait, this is only one side of the planet. What of the Western Hemisphere or Greenland and the North Pole? This snapshot is an actual photograph taken by a human hand in space. It is only a single moment in time. Strikingly beautiful, yes. An efficient way to monitor and study our planet? Not really. But as you may have guessed, we're already working on that. In 1960, the U.S. launches TIROS-1, the first in a long line of spacecraft that will revolutionize the way we predict weather. The TIROS satellites continuously orbit the Earth and capture regional cloud images every 30 seconds, 24 hours a day. Stitching these images together, we create the first mosaic of the entire planet. As decades pass, these weather satellite missions evolve into a highly diverse Earth-observing fleet. By measuring various wavelengths of light, many outside the small fraction of the spectrum humans see with our eyes, we began to see a bigger picture. 2002 brings a modern blue marble, this one of the entire planet. A true color, high-resolution mosaic made possible by combining the latest satellite imaging and processing technologies. This bird's-eye view of our planet allows much more than the prediction of next week's weather. We have now gathered decades of climate observations, time lapses, so to speak, of Earth's vital signs, Arctic sea ice cover, ocean temperature, greenhouse gases, and ultimately, global temperature. Scientists around the world are vigorously studying our planet, tracking changes over time, feeding models and simulations. As more and more data are gathered, identifiable patterns emerge. And what do we see? Sea ice and ice sheets are rapidly declining. The Earth is absorbing more heat. The oceans are warming, and in the process, climate patterns are shifting. This sphere that we humans call home is changing before our eyes. And we don't know exactly how this will affect our planet 50, 100, or 200 years from now. Ironically, the technology that allows us to see these trends was created by the very species that has the ability to affect, for better or worse, the future of this planet. Just why is the future of our pale blue dot so important? And why do we care? Consider the dramatic effects of climate change on the human family. Extended droughts, food and water shortages, increased extreme weather events. As sea levels rise, coastlines will be redrawn, and what will happen to the current cities and people who live there? Quite simply, climate change will affect all of us. Our species' ability to thrive, perhaps even survive, depends on humanity's stewardship of our pale blue dot. In the words of Carl Sagan, the Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit? Yes. Settle? Not yet. Like it or not, for the moment, the Earth is where we make our stand.
And now, we will experience one amazing story, the story of El Nino.
What's going on? El Nino. The ocean and atmosphere are a coupled system, working to balance the Earth's heat distribution in response to the uneven heating of the Earth's surface. This attempt at balance drives the major wind patterns and ocean surface currents around the world as they dance to move heat to where it is cold and cool where it's too warm. The trade winds are the prevailing winds in the tropics, blowing from east to west, from the Americas to Asia, and in part a result of this unequal heating. These winds were used for centuries by sailing ships crossing the world's oceans to conduct trade, giving them their name. Normally, the trade winds are strong, dragging warm water across the Pacific, where it piles up in the western Pacific as a pool of warm water. When the ocean waters move away from the coast of South America, cooler, nutrient-rich water from below moves up to replace it, a process called upwelling. This nutrient-rich water promotes the growth of plankton, microscopic plants and animals that are prey for small fish that, in turn, are prey for larger fish. The result? One of the largest fisheries along the coast of South America. But in some years, the trade winds weaken or even reverse direction, allowing